Welcome to this explainer. Today we're diving into a 4,000-year-old mystery tucked inside a math formula literally every school kid knows. a²+b² = c². We all call it the Pythagorean theorem, right? It's the absolute cornerstone of geometry. But here's the really fascinating puzzle. Long before Pythagoras was even born, ancient people all over the globe were already using this exact mathematical idea. They weren't just stumbling on it either. They were mastering it for massive engineering projects. So if the math predates the man by centuries, how on earth did he get all the credit? Well, let's find out.
So who actually discovered it? While this legendary equation bears his name, the true mystery is why. When you actually look at the historical record, the evidence is pretty staggering. You've got Babylonians etching precise numerical triples onto clay tablets, ancient Egyptians building flawless right angles with nothing but knotted ropes, and ancient Indian texts laying out this exact diagonal rule for sacred altars. This knowledge was totally global. So let's break down this brilliantly simple rule and unravel its incredible history, tracing how basic everyday observation evolved into the formal math we rely on today.
We have rock-solid proof that the math predates the man by centuries, maybe even millennia. From Babylonian scribes mapping the stars, to Egyptian land surveyors fixing property lines after massive floods, to Indian architects using precise geometry for their structures, this knowledge was literally everywhere. All these completely different early civilizations were independently arriving at the exact same fundamental truth about our physical world. But okay, before we journey back through that epic timeline, we really need to understand the basic tool they were all using to build their realities.
Let's look at how the actual math works. The whole thing applies to a right-angled triangle. You have two shorter sides, which we call the legs, and one really long side, the hypotenuse. The rule is elegantly simple, but absolutely powerful. The square of the hypotenuse is always going to be equal to the sum of the squares of the two legs. So for example, if your shorter sides are 3 and 4, their squares are 9 and 16. Add those together, and boom, you get 25, which just so happens to be exactly the square of 5. That means any triangle with sides measuring 3, 4, and 5 is mathematically guaranteed to have a perfect 90-degree right angle every single time.
Now let's look at the timeline here. You can clearly see a massive gap between the earliest practical uses of this geometry and the actual life of Pythagoras. He was born around 570 BCE, but look way back to 1800 BCE. Babylonian scribes were already deeply familiar with sets of numbers that fit this exact equation. They were calculating what we now call Pythagorean triples centuries before the Greeks even entered the chat. And they didn't just stop at 3, 4, and 5. Oh no, they were crunching much harder sets like 5, 12, and 13, or even 8, 15, and 17. The timeline completely proves this was a foundational tool of human civilization long before it was ever a philosophical concept.
Just look at this incredibly precise Babylonian approximation of the square root of 2. It was found on a 3,800-year-old clay tablet known as YBC 7289. It shows a square with its diagonals, and get this, it has a number accurate to the equivalent of 6 decimal digits. Let that sink in for a second. 6 decimal digits of precision almost 4,000 years ago. That's just wild. And it's not some isolated fluke either. Another famous piece, the Plimpton 322 tablet, has a whole list of these geometric number sets organized into a highly sophisticated table. The Babylonians definitely weren't just guessing. They had a profound computational grasp of this math.
Okay, let's travel over to ancient Egypt and see how this abstract math was built right into the physical dirt. In Egypt, geometry was literally a survival tool. Every single year, the mighty Nile River would flood, completely washing away the borders of their vital farm fields. To fix this chaos, land surveyors, who were famously called rope stretchers, used a super practical 3-step method. They'd take a single rope, tie exactly 12 equally spaced knots into it, and form a triangle with sides of 3, 4, and 5. Doing that physically forced the rope into a perfect right angle. They didn't need to write out some formal algebraic formula. This was a flawless, practical method used to redraw property lines and build those breathtaking pyramids.
And the ancient Indian civilizations were on that exact same wavelength. Dating back to around 800 BCE, you have texts known as the Shulba Sutras that describe the incredibly precise construction of sacrificial altars. Just listen to this translation. The diagonal of a rectangle produces both areas which its length and breadth produce separately. I mean, wow, that is the Pythagorean theorem, stated plainly and clearly hundreds of years before Pythagoras was a twinkle in his parents' eyes. It perfectly describes how the square on the diagonal equals the sum of the squares on the sides. Completely independently, separated by thousands of miles, these ancient cultures were zeroing in on the exact same geometric truth.
Eventually, though, we do arrive at the man himself, Pythagoras.
Living in the 6th century BCE, he was a philosopher, a teacher, and actually the founder of a pretty secretive cult called the Divine Brotherhood. These guys didn't just study math, they literally worshipped it. They believed whole numbers were the absolute, fundamental building blocks of the cosmos. But here's the ultimate twist in our mystery. We have practically zero surviving texts written by Pythagoras himself. We don't even know for sure if he was the one who discovered the proof, or if it was one of his brilliant anonymous followers. And the deepest irony? Their intense study of this very theorem led them straight to the terrifying discovery of irrational numbers, which actually completely shattered their perfectly neat whole number worldview.
So, if he didn't discover it, why on earth does he get all the credit? Well, the absolutely crucial point here is understanding the difference between an observation and a mathematical theorem. Knowing that a 3-4-5 knotted rope creates a perfect right angle for building a wall, that is practical, lived experience. You just know that it works. But using rigorous, deductive logic to prove that this rule definitively applies to every single right-angled triangle in the entire universe, no matter how big or small it is, that is formal mathematics. That is a proof. It shifts the knowledge away from the physical world of dirt and rope and directly into the pure abstract realm of universal truth.
As mathematician Bruce Ratner points out in this quote, the conclusion is totally inescapable. The ancients completely understood the relationship. The Babylonians had the computational math down, the Egyptians mastered the practical engineering, and the Indians had their precise geometric texts. While Pythagoras definitely didn't invent the rule from scratch, his name is forever glued to it because the Greek tradition was the very first to turn this ancient practical observation into a universally proven mathematical theorem. They provided the inescapable logic. They didn't discover the triangle itself, but they built the philosophical framework that proved exactly why the triangle behaves the way it does.
And honestly, that exact framework of mathematical proof has completely shaped the modern world. Today, this ancient rule is everywhere there's a right angle. Obviously, architects and civil engineers still use it every single day to ensure skyscrapers stand tall and bridges don't just collapse. But it goes way, way beyond that. Whenever a computer graphics program calculates the shortest distance between two rendering points in your favorite video game, or when your smartphone's GPS rapidly navigates your driving route on a digital map, it is relying on this exact same underlying combination of squares and roots. It's literally the hidden engine powering our entire digital navigation system.
So this isn't just some dusty schoolhouse formula you memorize for a geometry test and then immediately forget. It's a universal code, one that has guided human engineering and discovery for thousands of years. The Babylonians saw it hidden deep within their base 60 numbers. The Egyptians felt it in the tight tension of their knotted ropes along the muddy banks of the Nile. The ancient Indians visualized it in the precise diagonals of their sacred, fire-lit altars. And finally, the Greeks took all of that physical intuition and transformed it into rigorous, undeniable mathematics. It's an incredible shared human heritage that completely transcends time and borders.
Pythagoras may not have been the very first person to discover it, but his name has become the enduring symbol for one of the most powerful and beautiful formulas in human history. And it leaves us with a pretty profound thought. If a single geometric truth can bind ancient Egyptian rope stretchers directly to our modern digital GPS networks, what other ancient secrets are quietly running the world around us right now? If you want to uncover more hidden histories of the universe and see how mathematics truly shapes our reality, make sure to subscribe to the Code of the Universe channel. Keep learning, stay curious, and I'll catch you in the next explainer.